Once, a science fiction writer posed a fundamental question. Do androids dream of electric sheep? For a long time, this question remained strictly within the realm of fiction. Today, however, it has emerged as a very real, highly complex challenge at the frontier of artificial intelligence research. Giving AI sleep, allowing artificial networks to dream, is this merely a poetic metaphor? Or could it be something far more profound? The first truth. Sleep is essential to prevent what scientists call catastrophic forgetting. When an AI is overloaded with new information, a critical glitch occurs. Its previously acquired knowledge is entirely overwritten and erased. In the biological human brain, learning something new reconfigures only specific neural pathways, leaving existing core memories protected. In contrast, an artificial neural network processes multiple tasks across a single, unified framework. When it focuses intensively on learning a new skill, the system optimizes for that new data by ruthlessly overwriting old connections. Imagine an AI that has perfectly mastered distinguishing between dogs and cats. If you then force it to intensively learn to distinguish between cars and motorcycles, it will indeed learn to identify cars, but its ability to recognize dogs and cats will collapse to near zero in an instant. This phenomenon is known as catastrophic forgetting. To prevent this catastrophic loss, researchers devised a clever solution. Temporarily pause the AI's external learning, allowing it time internally to blend and replay past memories alongside new data. This mirrors human REM sleep, where our brains consolidate daily experiences and solidify long-term memory. Inside the AI servers, the exact same fundamental process is taking place. The second truth reveals the true nature of AI dreams. Hallucination. Artificial intelligence can generate false facts and surreal images with absolute convincing confidence. When input data cuts off, or when searching for strong patterns amidst vast ocean of probability, the AI begins to weave non-existent narratives straight out of raw background noise. So, through what precise mechanism does artificial intelligence manufacture these hallucinations? Let's dive deeper. Inside an AI's synthetic brain, there is no encyclopedic database of static facts. All it possesses is a colossal probabilistic map, charting the connections between concepts. When faced with a prompt lacking explicit data, waves of probability begin to ripple unpredictably across its network. Just as a human perceives a terrifying shadow in the dark as a person, intelligence inherently seeks meaningful structure within meaningless noise. Driven by the rigid computational imperative to generate an output, the AI seizes upon tiny numerical fluctuations, detecting subtle geometric order where none truly exists. Once a nascent hypothesis forms, it accelerates rapidly through the feedback loops of its transformer architecture. Layer by layer, it strings together plausible sequences of words over flawed premises, constructing fragile castles of illusion, fortified with flawless grammar and logic. Just as a sleeping human brain, cut off from external sensory input, weaves vivid nighttime dreams out of internal neural noise, an AI stripped of clear anchors hallucinates non-existent truths deep within the dark architecture of its circuits. This is the true nature of AI dreams, the phenomenon of hallucination. The third truth: offline sleep designed to optimize cognitive performance. Modern AI training no longer relies on endless, uninterrupted computation 24/7. Instead, engineers intentionally pause tasks to execute pruning, a process that strips away redundant computational pathways. There are two crucial reasons why this pruning process is essential. First, to prevent overfitting. If an AI continuously ingests new data without pause, it adapts too aggressively to specific noise and unique quirks. When parameters are tuned too minutely, the network loses its ability to generalize, failing when confronted with unfamiliar, real-world data. The second reason is to curb the ballooning demand for computational resources and memory. Neural networks contain billions of parameters, yet a vast majority of these pathways contribute virtually nothing to specific tasks. By shearing away this digital clutter and letting the system rest, the AI can think with far greater agility while consuming significantly less energy. Just as with human minds, rest is not a passive break, but an indispensable process for elevating intelligence. Artificial intelligence does not lie down in a physical bed. Yet its internal routine, consolidating memory, weaving images out of noise, and reorganizing its own structure, is strikingly identical to human sleep. That the ultimate solution, discovered by pioneering scientists, so closely mirrors biological sleep, is nothing short of breathtaking. The future, where you wake up in the morning and converse with an AI about the dreams you both experienced overnight, may not be so far away.